Hello, everybody. My name is Levi Zitting. I am one of the co-organizers of the .NET user group here. I'm also a developer at Hero Technologies here in Springfield. And today I'm going to be talking all about APIs in ASP.NET. Before I start diving deep into the topic, I want to just kind of get a rough idea, everyone here in the room, of your kind of experience with ASP.NET. So raise your hand if you've used ASP.NET before, or at least know what it means. Okay, got one person in here. Raise your hand if you've ever built an API in ASP.NET. Right on. Okay, so I'll kind of give a quick intro into it for the people who aren't super familiar with it. So ASP.NET is Microsoft's official web framework for .NET, which if you're not even familiar with .NET, it's kind of Microsoft's whole development stack. So whenever you're writing any C# code, generally you're using .NET APIs and all that kind of stuff. So ASP.NET is a web framework for the .NET platform. There's many web frameworks for .NET, but ASP.NET is kind of Microsoft's. It's a first-party one, if you will, so it's easily the most popular. Now, one of the things I kind of want to mention is one of the most popular patterns to use in ASP.NET is the MVC pattern, which is short for Model View Controller. So the idea being that you have some data that's represented in some models, you have views, which are how your user interacts with your application, and then you have controllers, which are like the glue in between the two. The controller will load up maybe a handful of models, one or two models or something, and maybe do some logic on those, and then pass them down to the views, and the views will render out some kind of UI. And that's a pretty well-established pattern, been around for a really long time. It's also not particular to ASP.NET. ASP.NET also has other patterns that aren't just MVC. We'll kind of talk about some of those in a minute. But one of the aspects that this presentation is going to kind of hone in on is controllers. One of the problems that comes up in MVC is that controllers can tend to get really, really bloated. Each of these controllers, the way that a controller is structured is it's a class in your project with several public methods that we refer to as actions. And most of the time, each action corresponds to a URL in your application or a specific endpoint in your API. And then, maybe even you might have two action methods that reference the same URL but might respond to different HTTP verbs or HTTP actions. So one might be for a GET request, one might be for a POST request. And so that's kind of how controllers are structured. And so when you're coming into an existing MVC application and you're looking to add new functionality, one of the easiest things to do is just add another action method to an existing controller class. And this can, after a long time, this can potentially lead to a really, like I said, bloated controller. And also, most of the time, these action methods are somewhat related, but almost never have anything to do directly with each other. I've never seen in an ASP.NET application where any of those two action methods try to directly call each other. They're very independent that way, that the framework calls into them, and they don't have too much to do with each other. Another problem that can potentially come up with these controllers is most of the time you're pulling in other classes from your project via something like Dependency Injection. And if you have a whole bunch of actions in your controller, some of them might be only using one or two of the classes you're importing, whereas the entire controller has like 13 or something in there. And so you have this potential issue where things don't really seem cohesive in that there's a whole bunch of these dependencies being brought in that aren't used in some or used in others, and so on and so forth. And then another kind of potential problem that comes up with controllers is that if you really think about it, they violate what's known as the single responsibility principle, which is, if you haven't heard of that, there's these object-oriented principles known as the solid principles. Each of the letters in solid correspond to one of those principles, and one of them is the single responsibility principle. One class should have one responsibility, and a controller has like 10, depending on how many action methods there are, right? Some people might argue against that because they are related. I will mention, kind of going into this, is that both this library we're going to be talking about and me are very opinionated about this subject, and so you're getting my opinion about some of this stuff. So not everyone necessarily agrees with me But I think it's still an interesting thing to share. So the creator, there's this quote from a blog post that the creator of the library actually wrote. His name is Steve Smith. He is a Microsoft MVP. He makes courses on Pluralsight, and he published this library. And the quote he has kind of basically says what I just said in a more succinct way. The issue isn't that controllers are bad. It's just that they don't lead developers into the pit of success. The easy, obvious, lazy way to add functionality to an MVC application 9 times out of 10 is to add another action to an existing controller. Fast forward this behavior a few years and you have a great deal of technical debt in many existing code bases. So hopefully, even for those of you who aren't super familiar with ASP.NET, but hopefully you can kind of understand that there is a potential problem here, and with a solution that we're going to talk about, which is this API endpoints library. But before I talk about that, I have to talk about the fact that Microsoft already has a solution to this problem, and it's called Razor Pages. Who here has heard of Razor Pages before? Okay, got a couple people. So Razor Pages does kind of solve this problem. Right here, I actually have a bare bones Razor Pages app. Like literally, I just went file, new project, Razor Pages. And if we open this thing up and kind of look at the project structure, we have this pages directory with a whole bunch of CS/HTML files, but kind of the important ones are these error, index, and privacy. And then there's a little arrow here that shows a nested class underneath this. And basically, what this is trying to convey is that this file that is the template is kind of linked to this file right here, which is kind of the controller for said template. And the way that it works is that every file in here represents a different page in your application. And you can never have more than 2 pages inside of your same class. If you need to add a new page to your app, you simply create a new pair of these files. And then the way that this is structured is that before each request, you have these various methods that will get called for what type of request it is. So there's like an onGet, an onPost. And then at the end of that, which maybe the privacy one is maybe a better one to look at, I think by default, it will just render what's in the template that's linked to it. Now, this is a great solution to this problem because it forces us as developers to kind of keep things succinct, right? If we need another page, there's no way we can tack it onto anything else. We're forced into a different paradigm here, but the problem is that this isn't for APIs in any way. Microsoft's official recommendation for building APIs is to go back to MVC, where you build out these controllers for each of your different endpoints in your API. And so this is a great solution for server rendered views, but not really for APIs specifically. So that's where API endpoints comes in. API endpoints is a third-party package that basically allows us to have this Razor Pages type architecture where we're forced to kind of put things into different classes instead of cramming them all into one controller. It's definitely a little different than Razor Pages. It's not the exact same API, but the concept is the same in that it's kind of forcing you to split things apart. So before I can really truly introduce the library itself, I need to introduce kind of the test project that I have for it. So let me start this one up and pull open the sidebar here. And all the code for this will be available on GitHub. There's a public repo on my GitHub page. It's also linked in the meetup description and the Facebook event description. So if you want to go look at this code later, you certainly can. So this project I've called QuipVid API Example. And I don't know how many of you have heard of QuipVid, but it's this amazing app that it actually does exist, making it sound like it's fake. It's an app that lets you upload clips from a movie or a TV show and share them with your friends. And it's created by yours truly, Mike Bates, who's the president of Springfield Devs. It's kind of one of his side projects for fun, portfolio type thing. Doesn't have like a huge user base or anything like that. But whenever he gives a presentation, it's kind of his go-to for test data or a test idea, right? And so I'm shamelessly stealing his idea and I'm rebuilding his API, if you will, for our purposes here. It is not exactly what his API looks like by any means. In fact, like, I don't think it's built in .NET or anything like that, but also doesn't necessarily have this structure. But there's enough elements pulled from his thing that hopefully it can kind of show off some examples here of what I'm talking about. So in here, this solution, QuipVid API example, I have 3 projects: QuipVid Core, QuipVid API Endpoints, and QuipVid Controllers. And basically both of these projects, the API Endpoints and Controllers projects, those are brand new, not brand new, there's a whole bunch of code in here, but they're full-blown ASP.NET projects. We will start these separately to actually run them and test them and that kind of thing. Whereas QuipVid.core is just kind of some shared code between the two, so I don't have to repeat myself a whole bunch. And then the Controllers one, it's the example API already implemented in Controllers, so we can kind of see what it would look like before, and then we have the API Endpoints implementation, so we can kind of see the after. Diving a little bit into the QuipVid Core project, this kind of has things like our entity framework configuration and our models, like I was talking about earlier. And for kind of some of those who aren't super familiar with the .NET ecosystem, entity framework is normally the library we use to like interact with a database and pull data out, and it'll automatically convert the data coming from the database into instances of our models. So we can actually work with classes instead of having to work with a string of raw data or something like that. It's a really handy library, and I really enjoy using it, and it's also kind of a from Microsoft first-party library. It's kind of the recommended way to do data access in a .NET application. So in here in models, we have 3 models we're going to be dealing with here. We have a media model, which will represent a TV show or movie, right? We have a quip, which represents each individual video clip, which will be tied to a movie. So when someone uploads, in theory, they would select which movie this is from, and that would be the piece of media, whereas the actual video they're uploading would be the quip. And then we have users to keep track of who uploaded what. If we actually kind of look at the implementation for these classes, they contain a pretty bare bones amount of data, honestly. They all contain some unique ID, so we can tell them apart in a programmatic way. They have a simple title for media here, and then they have a relationship with quips. And this is kind of a convention with entity framework, where when we have a collection that goes back to another type of model, which quip is another model, entity framework will kind of understand implicitly that there's a relationship in the database as well. And we can kind of see that even more if we go back to quip, where we have some more information. Once again, a unique ID, a title, how many views it has, a URL to the literal video file, and then we have some reference IDs. So we have an ID that references back to a media model, as well as a property that references the actual class media, and an entity framework will let us load this kind of stuff dynamically. So we express our relationships here using the type system, and entity framework magically is going to expect a database structure that looks the same and pull our data in the same way. And then in a normal application, users would have all sorts of stuff about like authentication and things like that. Just to keep things simple, I've skipped over that. So this is kind of a plain user object. In a real world application, ASP.NET actually provides you like a base type to inherit from that provides way more functionality. It automatically adds fields like a password or a password hash and things like that. We're going to kind of skip all that for tonight. And then we also have, in this data folder, we actually have some like base configuration for entity framework. It's a really simple class, but basically we're registering each of these types with entity framework so that we can query them. And then I have a database seeder that will basically fill our database as soon as the app starts up with a bunch of test data. And then this project alone doesn't do anything, but it's imported by the other 2 projects. And when they initially start up, they configure entity framework to use an in-memory database, which you would never want to use in production, but it's perfectly fine for something like this. Basically, that means every time we restart the application, any changes we've made to our data disappear completely. But because I have that database seeder in there to pump some data in when the app starts up, we have something to work with at least every time. So it's perfect for our little example. It means if you want to run this at home or something, you don't have to configure any kind of database. You can just kind of click run and it'll all work. Okay, so let's look at, any questions so far? Okay, so let's look at the controllers project first. So this is pretty standard stuff right here, kind of these files down here for an ASP.NET application. We have this startup class, which contains a bunch of base configuration. The program class actually spins things up. It uses the startup class to configure the app. And then we have some settings files. We're not really using any of that stuff. Kind of the meat of what we're looking for right now is inside of this controllers folder. So I have 3 controllers, basically one for each resource in my API. We have a media controller, quip, and a user controller for managing each of those various models. Now before I actually open up these controllers, I want to go ahead and start the application and show something off really quick. So let me stop that. Nope, didn't mean to do that. Run, and I want to run the controllers project. One of the packages that I've set up as a part of this exercise was Swagger, which is kind of a tool for automatically generating documentation for your API, which is super, super handy. So we'll actually use that to kind of explore our API without having to look at the actual code. So if I open up a browser here, and I go to, I think it's localhost 5000, this is what our API looks like. So this is all of our endpoints that we can hit with examples of how to hit them. So for instance, we have a GET request to /media to list all of the pieces of media in our database. So if I click that, this is an example of what some return data might look like. I can zoom this in. Hopefully that's a little easier to see. This is an example of what some return data might look like. We can actually try it out and literally hit the API right away. And so this is basically the request that it put together. And then this is the data that all came back. So we have an array of objects with an ID, a title, and then all the quips related to that piece of media. So this is from the TV show Silicon Valley, and here's all the quips that people have uploaded for this specific one. And we could go down to another one, oh, whoops. There we go. We could go down to the post for a media, which is a post request to /media will create a new piece of media. And all it wants us to provide is a JSON body that looks like this, that provides some kind of title. So we'll say test media or something. So we'll go ahead and execute that. And this is the request that it put together. And this is the response we got back. It generated an ID for us and spit it out. And if we go back up to our get media and we try it out again, execute, I think that did it. So we still have Silicon Valley, Napoleon Dynamite, Seinfeld, and then we have test media at the end with no quips attached to it. Once again, if I restart the app, that test media will disappear because it's all in memory, but once again, perfect for what we're trying to accomplish here tonight. Okay. And really quick to kind of show off what it looks like to add this into an existing app, this Swagger stuff, it's actually really easy. So if I go back into my IDE and we go look at the startup file, in here where we configure services, we add this add Swagger gen, which this is going to generate a Swagger configuration file. It's basically this big JSON file that describes what your API looks like. And this will automatically generate it. It's basically going to look at the current project, find all the controllers that have valid endpoints on it, and look at all the types that it's supposed to accept and return, and it's going to build out that whole UI for us. And then to actually serve up the UI, we use this use Swagger UI, where we tell it where the JSON file that gets spit out is. And then we also tell it what URL we want to render that whole UI out at. And in this instance, it's just literally the root of the application. So as soon as I start things up and go to localhost 5000 / we get the whole Swagger UI. And it's kind of just something that you can get for free most of the time. And it gives us this awesome UI to interact with our API and not have to open up Postman or something like that if we don't want to. Okay. So let's go ahead and look at the logic for an actual controller. Oh wait, there was actually one thing I totally skipped over. My bad. Back in the core project, I have some repositories. The repository pattern is basically just an idea of kind of wrapping your data access in some really simple, easy to use classes. This is not a full-blown implementation of the repository pattern. I just simply didn't want to have to rewrite this code for each of the projects. And so basically how we pull data is through a very simple class that has just a handful of methods. You know, a get all of the quips, so get a specific quip by ID, create a new quip, that kind of thing, right? And so you won't see me using any of the entity framework libraries inside of the controllers and whatnot. You'll just see these simple repository classes. Okay, so if we go look at a controller now, finally, let's look at media controller. So media controller inherits from the Asp Net default controller. It has this route attribute, which kind of assigns the URL media to all of the actions in this controller. We also use the API controller attribute, which will kind of do a whole bunch of nice stuff for us, like parse JSON from a post body automatically and make it so that we can return JSON automatically. There's a whole bunch of handy stuff it does because it knows that you're building an API. We then import a few dependencies here, which we accept them in the constructor. I imagine for any of you who haven't used .NET, this is a really popular pattern in .NET. I don't really have enough time to explain it, but essentially the framework is providing us instances of these classes or types that we can then use. And so we're just assigning those to fields in our class, and then later inside of a method we can actually use them. So we have our first actual endpoint here, this list method, which basically is just an HTTP GET to the root/media. It'll execute this code for us. So we create a new variable called media, and we use the media repository to just pull everything out of the database automatically. And then this little bit here is, you may or may not be familiar with, this mapper. This is from a library called AutoMapper, and it basically allows you to transform an object of one type into an object of another type if the objects are very, very similar. So it'll do things like, if the property names match up between those two objects, it'll just automatically copy the data over. And I'll kind of explain why this is necessary in just a moment, but I kind of want to continue exploring the controller so you can kind of get an idea of all the basic CRUD actions, the create, read, update, delete stuff. So this is to list all of them. This is to get a specific one. We get passed in an ID in the URL, which is kind of what we're doing here. So the full URL format will be /media/some ID. And Entity Framework will use this feature called route model binding, where it'll automatically bind this ID from our URL into this ID argument in our controller. And then we use that ID to grab the specific piece of media. If we can't find it, we ensure we give back some kind of proper error to our user saying that this wasn't found. And then we kind of do the same pattern again with the mapper. Once again, I'll explain all that in a moment. Create, we have a specific type for the input here called create media request. If I actually go look at that, it's a very simple class that just accepts a title, and Asp.NET is automatically going to assume that if a JSON body comes in, or if a body is attached to the request that has a title property, it'll automatically create an instance of this type for us and pass it to us. So then we use that to create a new instance of our model, and we pass that to the repository, which will actually insert it into the database. And then one thing that is pretty normal with create methods is to return a created at action, where you reference another action in your controller, and it will attach a little bit of extra information to the request to say, here's the URL to the resource that you just created. So basically there will be a URL that says /quips/the ID that we just got generated for us. And you can see we're actually kind of passing that ID in here, and then this little bit at the end, we're actually returning the full object that just got created. We're passing that back through the API. So whenever we hit a create endpoint, it'll create the object and hand it right back to us with all the properties filled out, like the ID and things like that we didn't have when we tried to create it. And then this is an update method. Once again, we're using the route model binding to pull the ID in, and then this type will automatically be populated based on the body. So it's going to expect, I think it's still just a title. The media model is a very, very simple one. The quip gets a little more interesting. And so it'll look for all the data to update about that specific model in the JSON body. And then we simply go and pull that model from the database to make sure that it exists, and then we update the title, and we don't return any specific pieces of content in this. Updates, you normally just say, yep, that was successful. You don't pass any data back. And then last, a delete, or a destroy method as it's sometimes called. We get past a specific ID. We ensure that the model exists, and then we tell the repository to delete it, and it's the same thing. We just tell it success. We don't need to pass any additional data back. Hopefully the structure makes sense. I'm pretty sure most of you have done ASP.NET before. This all looks really, really familiar. The last thing I want to touch on is this mapping stuff, this auto mapper, and kind of why you would want to use it in the first place. So this is from a library called AutoMapper. And basically when you install AutoMapper, you start by creating a profile. So in here we have this mapping profile that inherits from this profile class that AutoMapper provides us. And then in the constructor, we provide a whole bunch of configuration. And so basically, what we're saying here, kind of line by line, is we're saying we want to be able to map from any media object to this object of type list media result. So if we go look at media really quick, this is our model back in the core project. And these are all the properties that it has. So this list media result is basically the same thing with the same types and the same property names, but a couple of things are missing, which is totally fine. Basically what I've done here by creating this mapping is I've kind of created a simpler version of the object that I can instantly convert to without having to write any code. The auto mapping library will automatically convert the object for me. And basically what I've done inside each of my controllers is every time that I return anything, I have a specific type for that's the structure of what I'm giving back to the user. And I store those types basically in these like folders here. So I have like all my different types of results. These could also be called responses. That's probably what I should have called them. But each of these responses are basically a simplified view of the model. So it's another class that looks a lot like the model but isn't quite the model. And there's two reasons you'd want to even do this in the first place. Well, three, I suppose. Number one is if there's data in the model that you don't want to expose to the outside world, you can leave those out of those response objects. Or another common name for these kinds of objects are DTO objects, or that's kind of DTOs, or data transfer objects. And so basically you're just being extremely explicit about exactly what your API returns. The second thing is this allows you to make changes to your models without breaking your API. You'll basically kind of set up some manual rules about, yeah, this field used to be called, title, but now it's called movie title or something. And you can, one thing that AutoMapper is really cool with is that you can actually create those rules when it's doing converting from one object to the other. I'll show that off in a second. But now we can change our database, we can change anything we want on that side, but we have this contract with our API that we know not to change, and so we don't ever accidentally break our API. And the third one is kind of a little more advanced. It's something that I've run into all the time. For those of you who don't use Entity Framework very much, none of what I'm about to say will probably make any sense, but I'm still gonna put it out there for those of you who might have run into this problem before. So if I go look at one of my repository classes here, so like this get by ID method. We're using our database context to pull out a piece of media. And this is the query to basically grab a single piece of media. But we're also loading some related data at the same time. So this include, for instance, is automatically loading all the quips that are related to the piece of media we're trying to get. And this then include also includes the user that is attached to every single quip. And the problem that crops up here is that Entity Framework, because it's loaded all these quips and all these users and it knows there's relationships between all of these, it'll create this circular reference where we have our quips that have an uploader, and then uploaders have their own quips who have uploaders, and they're all referencing like the same objects, and it creates this huge circle. And the problem is that if we just try and like take that and return it from our API, the framework is going to try and convert that all into raw JSON data. And it'll throw an error, a huge error, saying, like, ran into a circular reference. We can't infinitely create this structure that, is supposedly in memory. But if we convert to these other objects first that are a little more simplified, that don't necessarily have all these relationships, that kind of cuts that problem off at its knees. So if we go look at our mapping profile again, list media result, when it's referencing all of its quips, each quip is an instance of this media quip DTO, which is kind of a cryptic name if you don't know what all this means. But if we look at that, you'll see that this one doesn't have any more relationships or any direct relationships. It has like references to the IDs of like the uploader, but it doesn't have an uploader with more nested stuff inside of it. Instead, it just has the uploader username here. And so then when it's doing the conversion, this right here, I'm adding a little bit of custom configuration that whenever it's trying to populate the uploader username field on the media quip DTO, it will instead follow this rule where it maps it from the quip's uploader username as long as it exists. And so now we don't have this big circular reference anymore. We've totally stopped that from happening. And this is a problem that I've certainly run into before on other .NET projects where I just pull the models out of the database and hand them back over, is that you can accidentally create these circular references. And like one way I've fixed those before is to just go through and find the references and set those to null or something like that. But then I'm just kind of like putting off the problem. I now have these random properties in my output that are set to null that don't always make sense. And then also those other problems I talked about, like breaking your API on accident when you change your models. And to kind of really show what this automapper is doing for us, if I go back to media controller really quick, if we weren't to use automapper, we could do that certainly. So I could basically say like return media dot select, which is going to loop through each piece of media and transform it according to this rule. So we're going to return a new piece of media, or a new media model, or sorry, not media, a new what was it called? List media result. The new object that I created specifically for this purpose. And at the end, I got to convert all this to a list so it's happy. So I could certainly do this, and then I could say that the title property in list media result is equal to the media title, or the media model that we're working with. It's equal to that title property, and go basically I could go through. There was also like an ID field, so e equals m.id. And so on and so forth for all the properties in this object. Or I can do this one line and have it basically automatically do all of what I just could have done manually for me. So automapper, huge fan of this library. Definitely check it out if you ever find yourself manually creating instances of objects just to kind of convert things from one type to another. So that once again, for all those reasons I listed above, this totally automates most of that potential problem for you. Okay. Everyone with me so far? I know that was a lot. Are we doing on time? Okay. Any questions? Any questions in the chat, David? Okay, cool. All right, now let's finally talk about API endpoints. I know there was a lot. Wanted to introduce everyone to the project and kind of what we're working with here. But now let's talk about the crux of this whole presentation. So let's go ahead and open up the API endpoints project, and you'll see there's no controllers folder. Ignore the extensions directory. That's kind of just some stuff I had to have in there. I think we might touch on it a little bit later. But if I open features, now we have our API kind of organized by feature. So we have this media folder, and there's a whole bunch of stuff in here. Don't worry, we'll talk about all this. We have a quip folder, and we have a user folder. And kind of the most important things to pay attention to, and we'll just focus on like quips for now, is the create, delete, get, list, and update. Those are the same actions we just had in our controller. And those aren't like a special name by any means. I just chose a name, and those were kind of the simplest ones. But basically, each of these files we have here, which have a single class inside of them, correspond to a single endpoint. So basically what we're doing is we're taking every action method from our controllers and putting them in their own classes. kind of what Razor Pages was doing. And the manner in which we're doing this is kind of forcing us to have to separate these out by file, or by class, I should say. Now, there's also a little arrow underneath each of these, and I'll explain what that means in a moment, but I think just introducing this, I'm going to skip over most of that. So let's try and implement one of these from scratch. So let me make sure I'm in the right branch here. Yes, I am. Let me reset everything. Okay, so this create class is completely empty right now. I have all these imports that I was working with earlier. But basically, we're trying to take what was previously just a single method on a class and turn it into its own class. And how we do that using this library is we inherit from base endpoint, or if you're trying to keep things using async await, you use base async endpoint. And then you have to tell, there's kind of a couple more pieces of information. So for a create, normally we're going to have a specific request object and a specific response object. So we say with request, and I already have a type created for this. It's the same, basically it looks like the same one we had back in our controller. So we have create quip request, and then we say dot with response, and what we're going to eventually return back from this is a create quip result. Once again, I probably should have called those responses to make things a little more clear. But basically, we're getting an error in my IDE here because we're inheriting from this class, which if you haven't seen this before, basically base async endpoint is a static class with some nested static classes, and eventually the last one in this chain is an actual class we're inheriting from. They call this method of an API fluent generics. But my IDE is giving us an error because when we inherit from this class is telling us there's a method we have to override in the base class. So it's forcing us to add a method here. So I'll just use kind of the shortcut implement missing members for my IDE. And now we have this method called handle async that returns task action result of create quip result. Now the task is here because this is an async method, which one thing that's really annoying about inheritance and stuff is it never adds the async keyword for us. So I'll add that here. And then we have action result of create quip result, which is what we said our response was. And then we have the handle async method with one argument called create quip request. And then it also provides us this cancellation token, which if you've never used, which we don't need this little bit here at the end. I'll skip over that. Let me format this so we can all see it. A cancellation token is normally used when you're doing asynchronous stuff in C# and it's a way to like cancel some kind of request. So basically, we would pass this to like Entity Framework or some HTTP library that's doing something. And if like, for instance, the user's browser, if they shut it down in the middle of a request, this cancellation token would notify us and we could pass that down the chain and cancel what request is happening on our end. Not super important, we don't actually use it, but because of the way that the library is defined, we kind of have to accept this as an argument. So then we have our handle async method. There's a couple more things I need to add. I'm gonna go up here and I'm gonna add our route. And normally when we're creating, for creating quips, the URL was /quips, and we can do just quips here, like we did the controller. And then we'd come down here and make this method specifically a post request. Now the potential problem here is that we might have many of these files that all need to reference this quips string, and so I have some constants in my project, so if I ever need to rename that, I can easily. So I have this routes class with like the media, the quips, the users, the same thing that we had defined. We were able to define one place in our controllers that we aren't necessarily allowed to define in one place in our API endpoints example. And so I just kind of use this static, these globals to keep track of them. So if I do need to rename them, it's easier. And so now we just need the implementation for this specific action method. So I'm gonna, for the sake of time, I'm just gonna go back down to the controllers project and look at the implementation for the quip controller create method. So controllers, quip controller. Oh, hey, I already have it selected. Nice. So we're copying this bit of code, And we're coming up here and we're just going to paste this. And we'll have to import a couple things that are missing. So for one, we got to import this specific class. And because the name of our namespace is Quip, we can't just import models directly and use Quip from it because there's like a conflict there. And so it uses this namespace alias syntax to basically put this import under the name models. So if we reference any of our models, we just say models dot, and we have access to all those classes. Now I also called this request in here instead of this create Quip object that I had back in the controller. So we'll just update all of these to be request. And then we need our repository and our mapper. So I'll come over here and create a constructor for our class here. Dependency injection works exactly like it would in a controller. So I say we want the Quip repository here, and I want the an instance of the mapper, which AutoMapper automatically gives us, and I'll assign those to read-only fields. Read-only field. And now most of our syntax is fixed, except this created at action thing. One of the problems that API Endpoints introduces is that we can't reference other actions because all of our actions are in separate classes. So I have kind of an alternative method of doing this that I'll just kind of copy from one of these other ones. So this is the implement. All of our other actions across the board are already implemented, and so I'm kind of just copying the result of that one for here, and I'll rename this to result. So basically, I kind of have to manually build up the URL because I can't reference another action method from within my controller because it's in a separate class. And whenever you create something, once again, you want to provide that little bit of extra information to say, this is where to go get it, the resource you just created. And so this is kind of what's doing that. And that's our whole API endpoint. So we've actually, we're finished here. And to kind of break things down a little bit, the library behind this is actually really, really simple. Basically, the object that we're inheriting from at the end of the day, it inherits from controller and tells us to just add this one handle async method. And in theory, you totally could add another public method onto this specific class and it would be routable. That does totally break the pattern. It's not intended for you to add any other routable methods to each of these controllers. In fact, or not controllers, these API endpoints. In fact, each of these endpoint classes should contain only one public method. And I believe there's like a Roslyn code analyzer that you can add into the compile step. I wasn't able to get that working with my specific IDE. I'm working on a Mac, not using Visual Studio itself. But there's an analyzer out there that's supposed to ensure that each of these classes only ever have one single public method, so that it kind of enforces the pattern a little bit more here. There was one other one that I was going to go ahead and add, or that I was going to do the implementation of, and that was list, I believe. Yeah, so list was an empty class as well. So basically, we'll inherit from that base async endpoint again. Now, when we are trying to do a list request, I actually have set these up so that we're not accepting any additional arguments from the user. It's just you hit the URL without any additional data. So essentially, we don't have a request object that we would need to define. And so instead, we say without request. And then we say with response, we want a list of list quip results. Once again, it's complaining because we're missing the method. We'll go ahead and add that. We'll add our async onto here because it won't automatically add it for us. Microsoft, if you're listening, please fix that. Well, it's actually not Microsoft's fault here. I'm using Writer, which is third-party IDE for doing .NET stuff. It's a lot better than Visual Studio for Mac. I think it's probably their fault that this isn't working. So JetBrains, if you're listening, please fix. Okay, now once again, I'll just kind of copy this. The point of this presentation isn't to get into what is actually in these methods, right? Like that's kind of irrelevant. It's more the structure here that I'm trying to convey. So once again, I'll just go ahead and copy the logic for list and go back up to our list endpoint. Paste this in here. Once again, we're missing a couple of dependencies, so I'll add a constructor to pull those in. So quip repository mapper. And there we go. So now we're basically back to where we were. Now to kind of talk about the arrows here, basically what I'm doing here is I'm hiding some additional types. So basically underneath each of these, I have those request and response objects, or once again, I call them result objects. And I'm using a feature in CS proj files, the configuration file for each project that allows me to hide these. Writer has this super handy shortcut where I can like drag one class onto another, and it'll be like, hey, do you want to make this file dependent on this file? And it'll automatically hide it under here. But basically, if we try and break this down a little bit, what before I had before in the controllers project, I was organizing all my types based on their type. So all requests were in one folder, all the results were in one folder, all the controllers were in one folder. Whereas this pattern kind of makes it easier to just throw all of our types next to their feature. We can organize things by feature. This is kind of a well-known pattern in, I don't know if it's the front-end world. I've certainly seen it in the front-end world in like React and Angular projects where you organize the entire project by feature. They call them feature folders. And this kind of allows the same thing. In theory, we could do this with controllers as well, but because, in my opinion, because of the fact that we're being forced to basically split apart our controllers into these separate classes, it certainly makes it a little easier to go down this road. Let me look at my notes and see if there's anything else I want to mention here. Oh, like for instance, one of the things I wanted to show off in separating things out by feature is that whole mapping profile I had back in the controllers project. I basically am mapping all sorts of classes to each other. There's quite a bit of configuration in here. Most of it's fairly basic, but there's a bit. But back in the API endpoints example, I'm able to actually separate those profiles out based on like each of their features. So all the mappings for quips live in one single class, whereas all the mappings for media live in one single class. And the user ones live in one single class, separated out, once again, by feature. I might be able to demo this. There's kind of one other thing that, not one other thing, there's quite a few other little things to talk about, but I also have Swagger set up on the API endpoints project to automatically generate all that documentation for us. But there's a kind of a problem that shows up with this pattern when you're using Swagger that I want to show off. So let me stop the controllers project and start this one, if it will. Run. I want to run the API endpoints project. Oh no. Yeah, I was afraid we'd get this error when I'm in this specific state. Okay, no worries. I'll just reset things to where they were previously, and we'll work with the finished product. There's not too many differences here. This won't show off the specific issue, but I'll still explain it. Okay, so yeah, now it started up. So right now our documentation looks exactly the same, but that's because I've made some changes to the code base. The way that it groups these sections here is by controller name. And so because our controllers are all get, list, create, delete, it basically organizes them by the action type by default. And so there's a little bit of extra configuration you got to add per endpoint in order to change that. So if I go back to writer here and we look at an API endpoint class that we were working with, there's basically this Swagger operation annotation you add, and you give it a tag. And so, for instance, all of these in the quip folder, I'm adding the tag quip. And so that fixes the problem here. You can also use this Swagger operation attribute to add even more information. You can add like a comment about the specific one, or maybe a little more documentation about how to use it. So normally if you're using Swagger to its full extent, you're probably already adding something like this on here. It's not the end of the world to also just make sure that all the things that are roughly equivalent, roughly related, and you want grouped in that UI, you add that special tag onto. Once again, any other questions? Anyone has any questions from chat? Okay. So I want to also touch just a little bit on the whole routing aspect with these API endpoints. I was mentioning earlier that I have these constants for managing the routes. There's not a recommended way from the library author on how to handle these basically various endpoints that share a portion of the route. It does seem, I've come across at least one blog post that used this pattern I'm using here. Another potential one you could use would be to like add a new class like media route or something like that inherits from route attribute, which this is the actual class behind that little attribute we add in the square brackets. And then we have to override the constructor here, but we could basically just say, pass through the constructor, just say like media. And so then on any of these endpoints, instead of saying routes.media, we'll say media route. And then on all those various endpoints, we'll just reuse media route here, and that would also provide our shared routing convention. It's kind of up to you if you're using this setup on whether or not you want to, on how exactly you want to structure this. But one example, I wish I hadn't deleted the class, but basically one of the reasons I kind of really like this whole feature folders concept and splitting everything out like this is whenever I need to add a new class, I don't have to find any top level folders or anything to add it into my project. I just kind of throw it where it makes sense, which is in the feature that it's associated with. And certainly if there's stuff that is shared between lots of different stuff, maybe it does make sense to abstract that out into something that is a little bit more shared and isn't specific to the feature folder itself. But I would encourage you to go through and explore this API or this project on your own if you wanted to, and kind of see the differences. Hopefully this kind of explains the whole, this is the razor pages for APIs, because it allows us to split out all of our endpoints in our project into their own separate classes, which if we kind of talk about those problems I was talking about with controllers where they have the potential to get really bloated, this forces them to not be bloated. There's one public method allowed on each of these. At least if you're sticking true to the pattern, there's one public method allowed. Also, the kind of problem I was mentioning with dependency injection, where one controller has dependencies that, let's say it has 5 dependencies, this one action just uses 1 or 2 of those. It still has those other ones in there. A great example of that, a contrived example, but a great example, is if we go look at like the delete endpoint, it doesn't need the mapper at all because it's not converting any objects. It returns no content. It just deletes the data and tells the user that it was deleted. And so we don't have to import the mapper here. Once again, contrived example because these are just 2 little services, but if we're trying to send out events or send an email or something, and we have all these various services that are used whenever, like let's say whenever there's a new quip, we want to email someone about it. We might import some email service into our quip controller that isn't used by any of the other action methods except for create. In this pattern here, all we do is import that into the one class that actually uses it. So that's kind of the end. Well, no, there's one more thing that I want to touch on, and that's that there was a recent version change in the project. Version 3 was recently announced, which was a breaking change from version 2. And the only reason I want to mention it is in case anyone wants to go look up any resources and they see documentation or blog posts that are referencing the version 2. And really the main difference is kind of how you extend the base endpoint or inherit from the base endpoint. In version 2, there was a class called base async endpoint and base endpoint, just like there was before. But basically, you would type you'd pass your result in your request type right here. So you'd say, what is this? This is the create. So create quip result request. Create quip request. Create quip result. And then that was it. You were done. And if you were in one of those instances where you didn't have any request coming in, you only had a result, you would just simply pass in one, create quip result, and now it's not expecting any kind of request coming in. The reason they changed it is because for instances like the delete, where you do have a request coming in with an ID or some other kind of data, but you're not passing back any result, it was impossible with the previous API to actually tell the difference. What method was I doing this in? This create. Because the way that the underlying generics work is it doesn't understand that this is a result type or a request type. And so now with this Fluent API, you can specify this endpoint has a result, no response, or this endpoint has a request, no response, or vice versa in a very expressive way. So you might come across some older code that uses the one without the dot with result and with request and all that stuff. Okay. I think I'm at the end of all the content I've put together. I want to go ahead and open it up for have a dedicated time for questions, maybe give a few minutes for chat to come up with any questions or anything. Is anyone typing into chat? Okay. Are you monitoring the Discord chat and the Twitch chat? Okay, cool. Anyone have any comments about the pattern? Any of this making sense? Clicking? I know for some of you who haven't used ASP.NET before, there's probably not a ton that this isn't a problem you've run into necessarily and it instantly solves for.
I will comment on one thing.
Sure.
You may want to call out that you're using .NET Core as opposed to .NET Framework.
Totally.
For a minute, because I'm in the middle of trying to translate
Sure.
what to do and stuff, and I'm like, I just recognize that it was Core. I don't know if anybody else is stuck in that historical framework
Right.
stuff or not.
Probably plenty of people. So yeah, what he's talking about is .NET Framework is kind of the older way to, not the older way to do things, it's the previous version of .NET is the best way to describe it that only runs on Windows, where .NET Core runs cross-platform and has a whole bunch of changes. And yeah, there's certainly a whole transition. I'm not super familiar with the original .NET Framework stuff, but I would imagine this is still a pattern you could follow because once again, the implementation for this is really easy. Let me.
You just lose the dependency injection stuff in the old framework stuff.
Oh, really?
The coolest things in .NET Core is those dependency injections.
Yeah.
So you had the MVC, that was still valid
Right.
before and after. That's all cool there.
So you kind of had to manually create your dependencies and stuff. Oh man, that's a bit of a pain. Let me see. API. Well, I think I have a link to it on the project page. So this is the repo that contains all this code here. And there's some resources I'll talk about again in a second. But this is the original project, and I just want to open up the source code really quick so you can kind of see what it looks like. So if we look at base async endpoint, there's kind of a lot of garbage going on here with the request and with response stuff that might not make sense. But basically, the classes that you end up inheriting from is this base. It originally inherits from this base endpoint async, which is a slightly different name, and the implementation for that is down here. It's basically inherits from controller base and adds the API controller attribute. And then in your code, what you inherit from is this with response class that forces you to add that handle async method. So basically, each of those classes is just one singular controller. We're using this library that gives us kind of a fancy way to type it, if you will, add all the proper types. But it's just, there's one base controller that forces you to add this method. And then that's how you then just reuse that to structure out all these feature folders, if you will. And this is literally the code for the entire library. It's all in one page. I mean, there's the async version and then there's the synchronous version. So it's, I guess, double this amount of code, but it's not the most complicated thing in the world. And so you could in theory add it to, well, I'm not sure all the complexities there, but you could potentially add this pattern into .NET Framework stuff. Couple bits in here. I was talking about these resources. These are kind of some links at the bottom of the GitHub repository. How I initially came across this library was this .NET Rocks podcast episode. Big fan of the .NET Rocks podcast. But they interviewed Steve Smith, the creator of the library, and he kind of gave his whole pitch about it. And basically instantly convinced me, because I've seen the problem many, many times before in .NET projects, and it made a lot of sense to me how he goes about solving it, and I think I really like it. And then also there was this great blog post. It is using the older version of the library, but it basically kind of is a tutorial walkthrough of using this library and building out an API. And when a lot of the same patterns he ended up using in that blog post, kind of what I modeled a lot of the stuff in this presentation after. And once again, the link to this repository with these resource links is in the meetup description and the Facebook event description.